which one of them is correct for you. That is known as hypothesis. The entire process is known as hypothesis testing. Okay. Now let's see more things around it. What is the process and all that? The few things changes here in the sense that when you do with machine learning. First point is how do you find out if a prediction is say algorithm which is doing the prediction for you is correct or wrong. You validate with a lot of other data, isn't it? Okay, so you have some known data. How do you do the examination? If you have to plan an examination, how do you do that?
What is schedule?
Right. What will you do is you actually
make a plan.
You will first give a lot of questions to study, syllabus content to study, that is training the model, right? So this is the first phase where you are giving a lot of examples and all that to learn it. After that, you will give some questions which is not there in the first lot that you shared for learning. Understood, right? So, and new questions, you want to see how intelligent that, how well understood is that person. Okay, and you have something to cross-validate, isn't it? The answer sheet, the correct answer sheet, okay, master answer sheet and all that. For every correct answer, you will cross-validate, and for every correct answer, you will award some marks. For every failure, you will not give some marks. Okay, if not deducting, not give some marks, not give marks. So you might want to do this entire process with 10 different question papers, level 1, level 2, level 3, right? The better the candidate is performing with all the levels, you get more confidence, right? There is a mathematical approach, but this is what is meant by hypothesis testing. This is the process. Okay, you'll see here they have null value, not null value, a lot of other things, but essentially when you do it using scikit-learn, right? Okay, it is what it boils down to. You train a model with certain data, then validate the model with data which is not there in the training data. Got it, right?
The validation set is within the training set only?
No, it's generally. So if you get the entire data, you divide the data into maybe training 5 parts. Okay. 4 part you will use for training, 1 part for testing. Yeah. Makes sense, right? Okay, that is what you do.
What is validation set? What is test set?
So generally people break down the data into 3 parts. Okay, one is your training set, one is testing set, one is validation set. Okay, so what people do is using train set, people train with the model, and after training one shot, you use test data to test the model. Okay, and this test data and train data is keeps on changing. You don't want to test it with every time with the same data. You don't want to train with same data. So you have some data, you have entire data. You first divide it into 80-20 ratio. 20 becomes a validation set. It's kept very much aside. In 80%, it is again broken down a 20-80 ratio. Okay, 80 again from here is used for training, 20 for testing. Okay, and it keeps on changing. This is known as cross validation techniques. Okay. It keeps on changing. So different pair of test data is always used. Oh. Okay. Okay, different pair of text data is always used. Okay. Now, okay. Once you have done their training and testing and all that, you want to see with, okay, I am now testing with some data which I've never used at all. That is a validation set of data. Got it, right? So 3 sets basically. You might train and test multiple times. So you will use this train and test data randomly, and validation is for giving the final verdict. That's the whole thing.
This mixing method of training and test, we need to do manually or?
No, it's done by algorithm itself. You won't have to bother much around it. So most of these things are pretty much taken care by algorithm itself. Okay, the process. So that's why writing code becomes very important here, because there are APIs which will do this for you. Okay, you just have to know why it is required, how it is required.
So only if we are going for a machine learning career, we do need to know about how these algorithms are implemented from scratch.
You will automatically learn it. See, I'll tell you some real situations. All these algorithms is different background. Okay, like for example, you see this linear regression and logistic regression. They need this calculus background. Oh, yes, you go ahead and learn calculus. Then later on you'll see decision tree that needs your information theory and other background. See, all these things are coming from different sources of math statistics. Basically, all these are statistics modeling techniques. Okay, these are coming from different sources of statistics. Okay, one is coming from Bayesian theories, coming from probabilistic models. Your linear regression is coming from these calculus models, right? Then your support vector machine is coming from your 3D calculus, right? Because there you talk to plane and all the decision tree is coming from this other technique. So everybody has different roots. Okay, and frankly speaking, machine learning is more. It has a lot more details than your deep learning. Okay, deep learning is one theory around which it revolves. You understand that, you understand the entire thing. Machine learning, there is different information coming from this. I mean, this is what people face actually, because for each topic you'll realize you have to know one subject. Okay, so that's the whole thing here. So just keep connecting all the dots. Okay, there will be something which might not be clear now, or which might need a revisit sometime later after you learn. Okay, so this thing will happen. Okay, so now talking about hypothesis testing. So there is a term that is known as null hypothesis. Okay, null hypothesis. Okay, null hypothesis is is an accepted fact. Got it, right? It's an accepted fact. Is that good? Okay. Tell me some accepted fact. For example, sun comes up in the east. Comes up in the east. This is an accepted fact. Okay. You may tell me some more. Sugar sweetens the tea. These are some accepted facts. Okay. Now, these are some, I mean, or many such based on the context, right? Based on the problem that you're trying to solve, you will have to state your null hypothesis. I mean, these are null hypothesis, something which is true. Okay. Now what you have to do, okay, you are not required to do some experiments to disprove it. It's not that what you're required to. What you're okay, so what you have to do is from your problem statement, you have to derive this hypothesis. Got it, right? If you're able to do that, what does it mean? Your hypothesis is true. Got it, right? If based on your current problem, based on your current data, you have a hypothesis, and from that hypothesis you're deriving a hypothesis, it means your hypothesis is correct. Chosen one is correct.
That is for the given data set what we got.
A given data set, you are choosing one
Some
hypothesis.
new data comes, you may need to revise the hypothesis.
Right. Okay, I mean, it might, of course, if it is a good hypothesis, it will hold valid there as well. Okay. Okay, so I think I'm just trying to, I had some examples here. There was one intelligence example, generally people use it. So maybe there is one example here I will take. Okay, fine, right? Okay. Okay, so this is you can, so there is this is the thought process of a researcher or a consultant. Okay, what he thinks is, okay, if knee surgery patient go to physical therapy twice a week, okay, knee surgery patient goes to physical therapy twice a week, okay, instead of 3, recovery takes more time. Okay, you can see this this example is there in Statistics How To also. It's a very good website for understanding hypothesis testing. You might refer Statistics How To for this. You can note it down. Okay, so this is the what happens is, there are a lot of such cases when there's a new capsule in the market, right? Vitamin E capsule. You want to prove it, this is better. If you improve it, your chances of some diseases will be going down. How do you prove it? You cannot, and take it and tempt patients and prove it, because there might be other factors which can actually, impact. For example, if you like Biocon, you guys know, right? So Biocon comes up with a new capsule vitamin E, which claims that after this you'll feel much more energetic. Okay, you got hold of 20 people. Okay, 10 people, one group, 10 people, another group. You gave everybody capsule, but 10 people you gave capsule which is vitamin E in it. Understood, right? 10 people you give empty capsules, so that you have to maintain the same psychological thing, right? That you are having capsule. Then you start observing people. Okay, then you start observing people. Then there are a few things you need to consider. If people already do some exercise or already are active by nature, they will show some, whatever active measurement is there, they will show the activity level, right? Okay, but whereas you have to really find out other factors also which could impact the result, right? So these are the places where these things comes in picture. How do you prove such thing? Okay, like you are creating a new medicine, you are creating a new process, you are creating a new technique. How do you think that works? It uses hypothesis testing formula. Like, there's something like this. There's a doctor who thinks, if you go for 3 times physiotherapy, you will be doing much better than 2 times physiotherapy.
One thing I understood, as you said, how we're doing this null hypothesis, what are the parameters you're going to consider? How we are considering vitamin, the guy is taking vitamin E tablet, right? And vitamin, just normal vitamin.
How do you compare?
Yeah.
You will watch his lifestyle. Okay, it is very easy to find out if the person is active or not, right? If you see somebody jumping throughout the day, active, not taking rest, you can understand that person is not not sluggish anymore. Okay, but you have to compare. Okay, if he was already like this or if he is now like this. Okay, and you have to compare. You have to compare that. Just because he thinks he's active, he's become active, or because of the medicine he has become active. Understood, right? So there are a lot of other things that comes into picture and that helps you concluding this. But you have to, take a call there. You have to take a call.
Simple validation of the blind test. Two people, one day you are giving with a vitamin, another day without vitamin. You are calling and asking, are you active or not? So based on that also they can test it. That way also. So because the other guy don't know whether you eat the
right medicine or not. You want to take care of the psychological factor also. Okay, and still you want to get the right result. Okay, so I'll maybe okay. So here in this example, okay, and remember average. And here you'll always given a statement. Average recovery time is 8.2 weeks. Is it clear? Okay, so what is it? He's assuming that if anybody is going, only for 2 times physiotherapy, his recovery time recovery takes more time, and an average recovery time is 8.2. Okay.
Prove sometimes, example, 100 people dying, the one day he ate some sweet, he died means, then do you say there is the 1% probability that if he eats sweet, he will die like that?
Yeah, I mean, this is very abstract actually. To little more because dying is a very different case.
Yeah, there are so many scenarios, but can we take from this example, like who eats sweet as a one case? So one guy eats sweet, so 1%, if he eats sweet, he will die, or you need to consider all the.
Why are you after sweet? Just kidding. Okay, so I'm just doing it for this match. We can do it for that match also. Okay, so here what happens is, because of this hypothesis thing, he believes that mean is greater than 8.2. Understood, right? Mean means now because of this hypothesis, the researchers believe the average recovery time is more than 8.2, right? Mu means average recovery time is more than 8. Okay. Okay. And if the hypothesis is wrong, right? Because if the hypothesis is correct, what it means, if you should understanding that every data is normal distribution, what will be the mean of it? More than 8.2. Average is 8.2. Okay. If generally there are a lot of people with and of course people might be so a lot of people might be taking 2 times, okay, or maybe more than that. Okay, if you plot the curve, how many times people are taking this medicine, I'm sorry, how many times people are taking physiotherapy, you plot a normal distribution curve, isn't it, by default, right? Where this is 3 and there are people who are taking more than that. Yeah, Devi. Oh, okay, carry on. Okay, so we have this okay, so we have, so if the assumption is true, his mean will be more than 8.2. If everybody is taking, and sorry, his okay, so now if without if his assumption is true, mean will be greater than 8.2. Okay, but if his assumption is false, what does it mean? It means that without physical therapy, with 2 times physical therapy also, he would need lesser time. What he's trying to say here is, when you do 2 times physical therapy, your chances improves. What you're trying to prove is, the other way to think is, without that also it is the same. Why are you increasing my costs? Understood, right? A lot of these cases can, if you take this medicine 3 times, what medicine is yours in your house? So yeah. So if you take some medicine 2 to 3 times a week, your chances of immortality increases. Right. So you're saying that no, without that also you're fine. Okay, that's what we are trying to prove here. Understood now what we are trying to do here. Okay, so similarly, if you can prove that the mean is less than equal to 8.2, you disprove this hypothesis. Okay, if this is the situation, you prove this hypothesis. Now let's see. Okay, and this is done using z-test. Okay, you remember for normal distribution we calculated z-score. What was z-score? How much standard deviation are you away from the mean? Right, that is your z-score. Understood so far? Right. Okay, similar to this, I'll just take another case and we'll calculate z-score. Okay, so few things here. There is a principal in your school. Okay, you know a school, and he claims that his students are above has shown above average intelligence. Very weird claim, right? But he is claiming that. Okay, like a lot of these new school these days, they claim that and because of their teaching methodology, the students have higher level of intelligence. People do a lot of false claims. Okay, so something like this, a school principal is claiming. Okay, so what he claims is students above intelligence. Okay, his claim is his students have above intelligence. Okay, so of course he cannot do one thing. He cannot take every student and take their intelligence test, isn't it? He cannot do that. That is not possible. So what he does is he takes a random 30 students. Random 30 students, right? Picks random 30 students. Okay, and calculates their mean IQ, which is 112. Got it? Takes 30 students. Okay, calculates their mean IQ. Okay, so so now this is what his claim is, and the mean population IQ is, just remember this line. Sorry. Mean IQ is 100. Okay, standard deviation 15. Right? Mean IQ is 100, standard deviation is 15. Now you have to prove if the principle is correct or wrong. Okay, just remember. Okay, so what is your null hypothesis here? First, understood this problem statement? The mean IQ of the population is 100, standard deviation is 15. He chose 30 students, and in 30 students the IQ is 112. And you have to prove whether his claim is correct or wrong. Fine.
What is that mean IQ 100 means? It is their student or
No, general life.
General.
Okay, so if we can conclude that for all the students his IQ is greater than 100, then I mean the mean IQ is greater than 100, we can say they are above intelligent. And that's all. This is like well known number or fact.
Okay.
Okay, so you have a standard deviation of, so what is your null hypothesis?
All students have IQ above 100.
Right. Okay, that population mean has IQ 100. This is because this is what is known fact. Mean IQ of population is 100. Fine. Okay, now yeah, so we can say that mean mu0 is equal to 100. Right. Now what is, okay, now what is this is null hypothesis. Now there is an alternative hypothesis. Okay, what is your alternative hypothesis? So what the principle is claiming? Mu is greater than 100, right? That his students are above intelligence. This is alternative hypothesis. Alternate. Okay, so this is the alternate hypothesis. Okay, let's see which one. I mean, either we prove this or we disprove this, or if we disprove this guy, okay, this guy is correct. If you cannot do this guy is wrong. Okay, now let me plot the data. If I plot the data,
we can prove or disprove only his students, right? We can't prove or disprove the mean population.
Mean population, right?
We can't. That is the generic.
Right. From there, we'll try to prove and disprove this line. From the mean, from his data,
okay,
of that 112. Okay, so standard deviation may be something we already know. Right. From that data, we'll try to prove or disprove this line. Based on this the line gets proved. Got it, right? So if you have to plot the distribution, let's say this is the IQ. Say this is 80. So 120. So this should be 100, right? Okay, so if it is normal distribution, okay, then there is a level here alpha. Generally, if there is not provided to you, this is known as alpha. This is equal to 0.05, 5%. This is some alpha associated. Even if it's not given to you, you can assume that this is alpha. Okay, this is one. So now, what you have to do is you have to find out, this is the entire area of people, right? You have to find out this 0.5% of it. Okay, so your Z score is equal to x bar minus mu naught sigma standard deviation divided by square root of n. If you do all these things, what is your x bar? X bar is your current data sets mu. How much is that? 112, right? 112.5. Okay, 0.5, 112. minus, what is the total mu? 100. What is the standard deviation? 15. Okay. And what is the total number of sample students that is taken into account is 30. Got it, right? This essentially, this entire returns you 4.56. Okay, 4.56. Now, what does it mean? It actually means, see, when you do 0.05, right, you're trying to find out what is the area in here. Okay, so if you remember in, how do you find out? Okay, when you say 0.05, you have to find out top 5% of it. If you use Z-score, right? I'll just show that how it is calculated using Z-score. Okay, if you find Z-score, the value will be using alpha. You want to find out how much area is this side using Z-score, right? It is coming something like this, 1.645. I'll show how it is coming in a minute. This is coming, and here based on your Z, it is 4.56. Okay, so and what is happening because of this? Your 4.56, your this particular Z 4.56 is greater than 1.64, right? This thing is happening. When this thing happens, you reject null hypothesis. Okay, just I'll explain this one more time, but understand this. You are calculating from alpha, you are calculating Z score. Okay, Z score is how much area is in the top 5% of it. That's what it means actually. We'll see, see the formula, it's a little messed up. Okay, we'll see the formula. But what does it mean? 0.05, we are trying to find out, how much area is in the left hand side of it. And that is more than, so the graph is actually a little thicker. This is the assumed graph. Your graph is actually little thicker. That means more area is going this side. Understood, right? And if that is happening, you can say this, your graph is not really a normal graph, which is best. Got it, right? It's little thicker in the tails, right? If it is thicker in the tails, you conclude that you reject the null hypothesis. And when you reject the null hypothesis, what happens? If you reject the null hypothesis, the alternate hypothesis becomes true. Okay, so it might sound a little different. Okay, just keep this in your mind. Okay, this is how you do it. Take one or in statistics, how to write. There will be this example is also there. Okay, and there are a few more examples. You can try just referring it on. Try, and this, don't worry about this part, this form, this number. Okay, if you just
not like a rejecting, right? It is more than that.
Which one?
It's not like rejecting the null hypothesis, right? It is like a more than we are meeting, and then more than that, like that, right? The first point.
So here you're meaning that the mean IQ population is 100,
yeah.
And what this line proves is incorrect. So you're rejecting this null hypothesis.
No, it's not it's rejecting, or it is more than that, like that.
But if it is not same,
okay, not same. Okay.
Not same. So I mean, when you do this, you have it. I mean, the earlier example is less than
equal. If it comes to this side, means we can say
right.
Like both the hypotheses are not correct.
Because actually the best way to imagine this is understanding this graph wise. You can see more data coming here. If more data is coming here, automatically you can see more data going here. So the distribution is not correct. Okay, and that is why it might not be wrong.
So later we will connect how we use this.
So actually these things automatically get used okay, in when you do this cross validation. This thing internally is getting used over there. Okay, you have like in scikit-learn, you have cross validation APIs and all that. Okay, okay, if you do this. Okay, so this is a SciPy library. Normal distributed noise, random data, start model OLS. Okay, so a few things you might have to do. Otherwise, you can use simple cross validation. Okay, so okay, so you can see this. We'll divide the train test data into load, split, and all that. Okay, so this is what you say is much more robust way of doing things. Okay, where you don't have to deal with every hypothesis and prove it, disprove it. Here it will you can run all this in automation and everything will show you results. Okay, so see here 95% confidence interval and all those things gets dealt over here. Okay, so touch upon these topics once. Touch upon these topics. I mean the hypothesis. Just know good enough part of it. Revise little bit of integration so that Monday onwards we can start with machine learning. So you guys are not available on weekends, is it? Weekends?
This weekend I'm here.
Available. Just for this weekend. Oh, Devi also left. I will put him also. If you guys are fine this weekend, we can do weekend class. Because the other batch are also the same stuff.
Machine learning.
Same starting actually. You guys are fine. 9:30. You're fine. 9:32. 9:32. It goes to 12. Yeah, we're fine with that. We'll check with Devi Prasad and Sony. If both of them are fine, I'll drop you a mail back before today evening itself, so that we can. And I want to do some data analysis. And after some machine learning discussion, some assignment I want to give, which everybody would be solving open book sort of thing. Okay, so that's the idea. So you can form a two people team. So just that you're getting comfortable because you already have a lot of other commitments to take care of. You need that one-time coding thing. So that is also the idea. Okay. So there will be a class, and after that there will be some. Okay. So just if possible, just touch base on pandas. If not, that's okay. I mean, it's open book stuff. The idea is to connect all the things that you have discussed so far. We'll give you a problem. Okay. The idea is to do explorative data analysis for that. Okay. See you then tomorrow, most likely. I'll just check with Devi Prasad. I think he'll be fine.
Only one day or both the days? Weekend. Saturday, Sunday or only?
Saturday. Assume now for Sunday also. Okay. Okay, and let me confirm it.
And also, I think I have to receive that video recording for the past classes.
Yesterday you didn't get.
Yeah, I also.
You send Monday one. You send one, right? The Wednesday class I asked, he said.
So
I didn't receive any email actually.
You're not in the group.
Devi Prasad is there. Naveen is there. Shankar Spectra is there. Tonal is there. Gadrivan is there. Your Venkatesh, right? Yes. But not here.
I think one email was not delivered. When I repeat all the emails, one email was failed.
Which one is it?
Let me check.
No, not that one. Venkatesh 044. Oh, I didn't pay the actually. No, that's the reason it's not. Check it once. Venkatesh 044 at the rate of gmail.com. This is the last class video. Last class video.
Right.